I mean, the PDF will be up to be given in. Thank you so much. There's no penalties, just that you often miss assignments, and so you often have to talk to the instructor to make it homework for assignments. At this point, it's if you're going to add a class, it's done through a petition, and so you would have to talk to the department. And they would have to kind of initiate some paperwork in order to get because it's going to be created. So having to be kind of documented, and the instructor has to get kind of official consent. Besides that, there's no penalty. There's no anything. No. I didn't see any. You leave it up here on the slide. You can check the rest of the class, right? Here. No, you did not. I have to say my yeah, the joke. You didn't know about the joke. You know what it's saying? Yeah, you know what it's saying? Oh, it's kind of green. Ooh, it's kind of green. Oh, the mix is that. Wait, yeah. Check that out and say, hold her up, hold her up, hold her up. It's a shit like the one. I this guy's going to it's like our old family. And then you know, always started passing why. Yeah, trust me, that's a lot of it. Were you like, oh, you sure. I couldn't picture the no, I could. Do you walk like right? I'm really it's good. You want you're rocking by with the it's a lot more than just engineering. A lot of it is just no, I want you to have different classes. The report, the amount of report writing It's always gonna be more.
That's also on Wait, you
can, I want to.
I don't think that I don't like that much. I'm moving I think you have a number of things. Definitely have the 20 bucks. If you're gonna take the CMFGP test anyway, I'm gonna be a member, just takes the cost of it from like $200 or $300 down to $90. Your student we save a lot of money. Exactly. Oh wow. It's not pretty good. No, I'm not. Yeah, right. What is that? Wow. Are you really good? It's gonna be. I'm gonna try to vote for you. They're good as I've upgraded my computer. I get to have the new level. What did Firefox is using?
All right, it's 5:30, so let's go and get started. All right, good evening, everyone. How's everyone doing today? Doing good. I'm doing great. Thank you. Thank you for asking. All right, so today is our second ANSYS activity, so we're going to be jumping in ANSYS again. It's quite a bit different than our first activity, so we're going to be doing 3D first of all, and we're going to be working with a pre-made cap. So we're not going to spend any time today making the geometry. Okay. All right, so the scenario is this, and so we're going to pretend that we work for a bike manufacturer, bike design company. Okay. And what we are tasked with is we're going to be designing the crank for the pedal for the pedal. And so for this activity today, I kind of want you to imagine that you're designing, usually when you design a structural piece like this, you're going to design it for the worst case scenario. Right? And so we're going to design it for a case that, maybe someone's biking, they're going along the merry way, and then someone sticks a crowbar into the wheels, and so all of a sudden the wheels can't turn. Okay? So the wheels can't turn, but the person is still applying force onto the pedals. And so we want to test and see, if this bike crank, which is shown here on the left, if it's going to fail it. Okay. And so we're going to use ANSYS today to determine, if this bike crank is going to go push to fail. Okay. All right. So a couple of things. So I know this says going to post this today, but I had a busy day yesterday, so I kind of forgot. And so for the activity today, you're going to go to the website. So you can go to the Canvas site. Hopefully, I think everyone should have access to the Canvas site now. Okay. You're going to go to the Assignments tab. Okay. You're going to see that Assignment 2 is activated. Well, you see all the other assignments here. I'm the instructor. Okay. And then from the assignment, from the ANSYS assignment here, you can download the PDF. Okay. And so the PDF has all the instructions and kind of step-by-step, steps that we're going to follow today. And so if you want to kind of go ahead of the class today, then you can just follow the PDF. You're definitely welcome to do that. Or if you kind of fall behind and you need to kind of look at the instructions, that's there too. But I'm going to go through the PDF myself. But I think more importantly, you can download the CAD file that you need. Okay. And so for the class today, we're going to work on the CAD file here, the crank assembly. Okay. The second the second CAD file, which I think is Dutch or German or something, is another CAD file that you're going to use for an additional activity after today. Okay, but for today, you're just going to use the crank assembly .x underscore t. Okay. So for now, I'll give everyone a chance. Go ahead and log on to the Canvas site. Go to the assignment, download at least the CAD file, and then we'll open it up. Okay. So while you guys are doing that, in the meantime, you can open up ANSYS Workbench as well. Remember, ANSYS takes a while to open up, and they've installed ANSYS 2023. And so you can actually use ANSYS 2023, and hopefully that shouldn't have any if you're kind of moving files between here and home, then hopefully that doesn't have any kind of format. So I think that must have just happened today. I should probably buy an IT person. That must have been a lot of work to upgrade these to 2023. So does everyone have 2023 version on their computers? All right, awesome. So let's use that one. Okay. All right, so go ahead and start the 2023 version because it takes a couple minutes. Download the CAD file, and then we'll probably start in a couple. All right, so while you guys are starting that up, I'm going to go ahead and give a couple announcements. So, again, everyone's added to the class at this point. So for those of you that were on the wait list and just got added to the Canvas site, you probably might have noticed that there's a homework 0 where I had you guys send an introduction email. Okay, and so of course, for those of you who are added late, on Canvas will say you missed the deadline for that. But of course, I'm not going to leave you out to dry. And so if you were just added to the Canvas site, you can go ahead and send me an email. Just kind of introduce yourself, just so I can give you credit for that. Okay. So that deadline is kind of extended for that. And then besides that, I think that's it. All right. So any questions I can answer about the class or anything before we get started for today? Okay. All right. So let's go ahead and get started. Okay. So everyone has opened up ANSYS Workbench. Okay. All right. So the first thing we're going to do is just like we did last time, we're going to start with static structural. So you're going to go to the left-hand side here. Go to static structural and drag that into the project workspace here. And so that's going to create an object here, which is going to kind of house our project. All right, so first thing we're going to do, let's go ahead and import our geometry, right? And so if you remember from activity 1, in activity 1, we made our geometry from scratch. So we use basically the CAD software within ANSYS to do that. But that's usually not typical. So normally when you're working with FEA, when you're working in ANSYS kind of more out in the wild, you usually create the CAD file in another software. Most commonly it's SolidWorks. If you're in the aerospace industry, I know they use Kia a lot, but you often are going to produce the CAD file somewhere else and then import it into ANSYS. Okay. And so to import the CAD file into ANSYS, you're going to right-click on geometry here. Okay. And then you're going to go to this option here for import the geometry. Okay. And so when you expand that menu, you can see that you can click on the button for browse, and then you can go find your file. Okay, so let's go ahead and do that. So let's go ahead and browse for our file. And my file should be in the downloads folder. And then once you kind of find the file here, you can just go ahead and click open. And it should import without any issues. Okay, so after you import the file, you should see a green check mark next to geometry here. And the symbol next to geometry might change to a P. And that P is only just meant to indicate the file format for the file, which is a parasite. Okay, so is everyone able to upload or import the CAD file? Okay. No issues? Okay, good. Okay, so that's the first thing. So first new feature learned. Okay. All right, so the next thing we're going to do today is we're going to create a custom material file. Okay, and so if you recall from activity 1, we use kind of a built-in material property that was inside and already structural. Okay, so for today's class, we're going to use a but still a very common material. We're going to use aluminum. But we're going to go through the exercise of actually defining a custom material just so that you have that knowledge for it. Okay. And so to create a custom material, we're going to go to engineering data here. Okay. And we're going to double click on that. Okay. And so after you double click on engineering data, it should take you to this menu right here. All right, so you can see right away that we have our default material, so we have structural steel there, so that's good. Okay. But we're going to add a new material here. So if you kind of read this this text box here, you can see that we're going to click here to add a new material. Let's go ahead and do that. And so after we click on that text box, it's going to allow us to type something in there, so we can give our material a name. And so the material that we're going to add in today is aluminum. I would have to look up how to spell it. Okay, good. Right, and then specifically, we're going to use a specific type of aluminum, which is 6061 E6. All right, so after you type the name of your material, you can go ahead and hit enter, and so that's going to create a new material property there. Okay. All right. But what you should notice is that after we created this material, there is a blue question mark here. Okay. And so that's something that that you should get used to in ANSYS. And so what that blue question mark means is that ANSYS wants you to specify something before you continue. Okay. And so in other words, we're not quite done yet defining this material property, because all we've given it is just the name. Okay. So let's go ahead and define the properties for this material. Let's go ahead and click on aluminum 6061 T6 if it's not clicked on already. And we need to assign it some material properties. Okay. And so we're going to assume that this material here is an isotropic material. Okay. We're going to assume it's also linear as well. So we're going to assume it has a linear express strain. And so we need to assign the Young's modulus and the Poisson's ratio at least to this material. And so with aluminum 6061 T6 selected, you're going to go to linear elasticity. You're going to click on the plus arrow from that. Okay. And then from here, you're going to take isotropic elasticity, and you're going to click and drag it to aluminum 6061 T6. Okay. All right. And so by doing that, by clicking and dragging isotropic elasticity, we have defined our aluminum as a linear isotropic material. Okay. And then in the bottom here, you can see that before we move on, ANSYS wants us to specify the Young's modulus and the Poisson's ratio of this material. So it's gone ahead and highlighted it for us. Yeah. All right. So let me pause here. So any questions on this so far? Yeah.
Or when I click on engineering data, it took me to like a different screen.
You might have to reset the view. So if you go to view right here, you want to make sure that all of these are selected.
That outline wasn't there.
Okay, good. Yeah, for some reason, for some of these ANSYS is I think it's happened last week too. I think some of the views are kind of modified for whatever reason. And so if you don't have all the menus here that I have, try going into view and making sure that all of these are selected. So toolbox, outline, properties table, and chart. Okay. All right, any other questions on this? Okay. All right, so let's go ahead and specify our values for Young's modulus and Poisson ratio. Okay. So let me go ahead and open up the PDF again. And then from the PDF, you can see that we're going to assume our material here has a Young's modulus 1 times 10 to the 7th psi, and our Poisson's ratio is 0.32. Okay. So let's go ahead and assign these properties to our material. Okay, and you have to be careful here, because if you look at the units for our PDF here, you can see that the Young's modulus is given to us in pounds per square psi. Okay. But depending on your ANSYS that you're running right now, it might give you the Young's modulus in Pascal. Okay. And so before you enter any number, you want to make sure you change the unit for this. And so instead of Pascal, let's go ahead and change it to PSI. Okay. Just to make sure we're consistent with the material properties given to us in the PDF. Okay. All right, so I've gone ahead and changed the Young's modulus unit to PSI. Let's go ahead and assign this material. And so you can use scientific notation in ANSYS, and there's a 1E7, and then that will define the Young's modulus as 10 times 10 to the 7th power. And then our Poisson's ratio is going to be 0.33. All right, so you want to make sure you enter both, and then make sure that for the Young's modulus, you change the units to PSI. Okay. And so if you do that, you should get the following numbers here. So your Young's modulus would be 1 times 10 to the 7th PSI. Okay. And then what you should see is that the bulk modulus and the shear modulus will be automatically computed for you. And so remember when we reviewed strength of materials, right? You can compute the values of the shear modulus and the bulk modulus based on the Young's modulus and the Poisson. And so ANSYS kind of already assumes that for this isotropic. So you should make sure that all of your material properties match these numbers. All right. Any questions on this? You don't have to. So the units only matter for the Young's modulus. Okay. All right. So that's it for the material properties. So let's go ahead and close out of this. Okay, and so we're done here in Workbench. So we've imported our geometry and we made sure that our material properties are correct. And so let's go ahead and open ANSYS Mechanical. And so on the model button right here, let's go ahead and double click this. And so double clicking model will open up ANSYS Mechanical. So it's going to take a couple minutes. No ad today too. If your ANSYS opened up with that weird ad with like the YouTube link and stuff like that, in order to get rid of that, you can go to the left here and click on geometry. Okay, and so that should bring up this. So is everyone able to open? Yeah.
Is there a way to rescale ANSYS?
Are you getting, or is the text really, really small?
Yeah, like I can't see the drop downs.
Yeah, so if you're working on your laptop, what can happen sometimes that ANSYS has some weird interaction with the resolution of your computer. And so you may have to go into the settings and change the resolution to make the text look
Like my computer's display resolution?
Yes, your computer display resolution. It's really annoying, but yeah, it happens. Yeah.
You know, like what it likes? Is there a sweet resolution it likes?
Honestly, for I've seen it work for different laptops. It's different. You just kind of have to think around. MJ, you have a question?
Oh, yeah, it doesn't open.
It doesn't open?
No, the model open up.
Do you have the ANSYS Mechanical or is it giving you an error?
It's giving the error is a question mark.
Question mark on the geometry? Did you import it?
Yeah, I imported, I think it's yeah, imported with geometry.
Okay, let me I'll come around to you, but let me just try to move ahead. Okay. All right, was everyone else able to open up ANSYS Mechanical just fine?
Yeah.
Okay, yeah, question? Okay, I'll come around to you guys to do this. Okay. Let me get you guys up to the meshing part before we begin. All right. And so here is our bike frame. And so what you'll notice is that this is actually an assembly, right? And so we actually have several different parts here that are part of this assembly. But for this activity, we're really only interested in just one of the components or one of the parts. And so for all the other parts of the assembly, we're going to need to suppress them. Is there a question back there, guys? Okay. All right, and so suppression is something that we're going to do a lot in this class. And so when I say we want to suppress a part, all that means is that we're going to remove it from the. Okay. And so for this assembly here, if you open up kind of the plus arrow next to geometry, you can see here that we have three parts in this assembly. So we have the bike frame, we have the pedal, And we have this kind of part 9, a SEM 2 rev, 0.37, which I think is just a mating tool for the. All right, so for this activity, we're really only interested in the bike. So let's go ahead and suppress the other 2 parts. And so to suppress a part, you're going to right click on the part, and then you're going to click on suppress body. Okay. And so if you read the tooltip for suppress body, you can see that it says remove the selected body or body from the analysis. And any scope objects will also be. Okay, so that's what we want. We want to remove this. Let's go ahead and remove that. And then I'm going to remove this part 9. Okay. So suppression is very important because a lot of times you'll be given CAD geometries that have a lot of extra parts that you don't really care about in the analysis. Okay, because you guys have probably experienced this in your previous CAD classes that when you produce a CAD model, you really try to model everything. You go for kind of as much accuracy as possible. But what you'll learn very soon is that in FEA, a lot of times, we actually don't want to do run analysis on all of those parts because it's going to drive up the cost of our simulation pretty significantly. Okay, and so it's always a good idea to, whenever you're doing an analysis on FEA, to try to suppress all the parts that you don't need and really just focus your analysis on the parts that are going to. Okay. All right, so next thing we're going to do here is we're going to assign our material property. And so even though we've defined our aluminum in the previous step, we need to actually assign that to our part here. Okay. And so to assign a material to a part, we're going to click on that part from the geometry submenu. Okay. And then what you're going to do is you're going to go down to the bottom left of the screen, and you can see here that there is a setting for material assignment. Okay. And so you can see that the default material here is structural steel. So let's go ahead and change that to our aluminum. And so it should give you, and so as long as you define your aluminum from before, it should give you the option to do this. Okay. All right, so go ahead and change the material for the bike crank to aluminum 6061 T6. Okay. All right, so we've gone ahead and we've suppressed the unwanted parts of our geometry. We've gone ahead and changed the material. Let's go ahead and move on to meshing. So the meshing will be, I'm not gonna guide you too much on the meshing just because we just finished talking about meshing on Tuesday, and so I want you to kind of use what we learned on Tuesday to put a good mesh on this geometry. Okay. I will provide you with a couple new tooltips though. Okay. And some of you may have already done this in activity 1, but I'm gonna show you how to modify the mesh a little bit more than what. Okay. And so to modify the mesh, we're going to create 2 objects here. So we're going to create a method object, which is going to allow us to change the order and the shape of our elements. Okay. And we're going to create a sizing object, which is going to allow us to change the size of the mesh. Okay, so let's start with the method object. So go ahead and right-click mesh and click on create method. And then after we create the method object, we need to assign that to a geometry. We only have one part of the geometry here, so you're just going to click on the bike crank. Make sure it's highlighted green, and then you're going to go to the bottom left of the screen here and click on apply. Okay. And then from this automatic method here, you can see that we can change the shape of the elements. Okay. And so if you go to the bottom left of the detailed menu, you can see here that our method, we can change it to either tetrahedrons or hexahedrons or others if you want. Okay. For today, just kind of stick to either tetrahedrons or hexahedrons because that's all we've learned so far. So I'll go ahead and let you guys choose, which element shape that you want for this mesh. Okay, so that's the method object. Next, let's do the sizing object. And so the sizing object, just like the name implies, will allow us to alter the size of the mesh for our geometry or for a certain region of the geometry. So let's go ahead and create this sizing object, and let's go ahead and apply it to our geometry. And then once again, in the bottom left of the screen, you can see that we're given the option to change the element size. And so right now, the default should be somewhere between, 11.25 millimeters. And so if you click on this box, you can change that element size to whatever you want. Okay. I just put 5 in there for filler, but you guys can play with it. Okay, so why don't you guys play around with the meshing a little bit, and so play around with those settings and see how that affects your mesh. Okay? And then at the end, before we move on to the next step, you should have a mesh that looks satisfactory. Okay? And so while you guys are playing around with the mesh, I'm going to go around and help people because I know people are getting some errors. And then when I come back, maybe about 15 minutes, we'll go ahead and move on to the next step, which is oh, it's fixed.
Yeah.
Oh, perfect. Great. Okay. Okay. Good. Okay. Okay. Yeah, it's not a or it's part nice. So people can so yeah, so this is what oh, it's there. Well, I was gonna say they should be Saturday. I would and actually, those That's right. That's right. Yeah.
Like when you introduce yourself,
show you. I was about to say when I was I mean, last year. That's just great. It's just a while. That's why I love
I just don't want it to be said. What do you?
Yeah, it's got it. Okay, yeah, so we can't solve the way. Right now, you're going to.
If I go to the workbench,
It should have
no, it's fine.
Oh, yeah, so it's course, and so. elements anyway, we're gonna be, doing work for it. 4 times.
This one is.
But then for.
Oh, that's right.
Nothing. It's just. Hey, doing it. Pretty sure ANSYS can only run on. Oh, that's fine, yeah, that's just, so then if it says just warning, most, okay, so that is, I mean, you guys got it, but most of the time, warning is really for it. You shouldn't ignore it, you should actually do something about it. I usually just have. That's a macro care. There you go. Go ahead and click on the match. Easy to, oh, that's beautiful. Very nice. Oh, no, you're able to get execute now. Good. Let me check the number. And that was perfect. That's a very nice period.
Yeah.
I guess doing Noah, okay?
I mean, it's just like, it's still solid.
Yeah. And then. Yes. Yeah, I don't know, it's in a different place, in the different softwares, it's in a different place, which is kind of. You guys doing okay?
I'm trying to run many.
Oh, there's a limit, and actually, if you try to create a mesh with too many elements, so if you try to run a simulation with too many elements, ANSYS will stop you. If you try to create a mesh with too many elements, ANSYS won't stop you, but your computer will stop you.
It's not, I mean, now.
Usually it takes more than 10 minutes to create a mesh.
Or, I'm gonna go.
Yeah, yeah, I think it only did one. And so it looks like it's not PM, but I think there's one for you. Like, I mean, but I mean, you can finish it.
No, my.
Make sure feel it. But yeah, you can see how many elements in it. Sure, there, it's up behind. Oh, this is it. Yeah, so the other one is see it like actively dominant. Yes. Okay. And so it's really hard to get a match between most of the elements. Yeah, I want to appreciate yeah, it looks like it works. It looks like these are like, you can see it. There is a yeah. It's a nice question. All right, so it looks like everyone's got the mesh. Okay, so that's looking good. So actually, let me go ahead and make a mesh for myself. Okay. So I created a tetrahedron mesh just because I'm just using the default settings, but I know a lot of you use hexahedron, which is great. Okay. All right, so let's go ahead and move on to the boundary conditions. Okay, so remember that our boundary conditions are our loads and constraints. Okay. And so we have two boundary conditions that we need to add. So we need to add a fixed support. And so if you remember from the first activity, we use fixed support on the first activity too. And so a fixed support is just, basically you're specifying which areas of your model are going to be, fixed. And so it's not going to move, right? And so we need to do that for this geometry here. Okay. And generally, and so I'm not going to tell you exactly where you should fix it, but I will give you some hints. Okay. And so the reason I'm doing this is because, when you're kind of out there in the wild, doing FEA on your own, and some of you are actually already applying FEA to some of your student projects, it's great, okay? And so I kind of already had this conversation with a couple of them. So when you're going to apply your boundary conditions, you want to think about kind of the real life situation that your part is in, and think about what boundary conditions kind of make sense for that situation. Okay. Remember, the boundary conditions, what they specify is they specify any kind of external effects that are acting on your system. And so external things that it's attached to, maybe external forces. Okay. And so we have kind of two main external effects. So we have on the one side, we have the fact that this bike crank is attached to the main frame of the bike. Okay. And so where this bike crank attaches to the main frame, that makes sense to fix it there because the frame is going to be a lot more rigid than this bike crank. Okay. And so think about where, and if you kind of forget which side is which, right, you can kind of unsuppress this pedal and know that this pedal is kind of right here. So the other side is kind of where it is. So kind of already given you. And so, you want to apply the fixed constraint, where this bike crank attaches to the frame. And then the other thing that we're going to apply here is a force load. Okay? So a force boundary. And so the force boundary condition is going to represent any kind of external force that's being applied on your geometry. Okay. In this particular case, the force that we're going to apply is going to come from the person pushing down on the pedal. Okay. And I will go ahead and give you the magnitude because I want everyone to use the same magnitude of force. Okay. And so I want everyone to apply 100 pounds of force onto the bike.
Not Newton.
Not newtons, pounds. Okay. All right, and so when you go to apply your force boundary condition, remember you have to specify two things, and so you have to specify the location where that force is going to apply, okay, and you have to specify the direction of that force vector, okay. Okay. And so if you remember from our first activity, when we went to apply our force boundary condition or our pressure, we changed our application mode to components. So let's go ahead and do that. And so under this defined by setting here, you're going to change that to components. And what that's going to allow you to do is it's going to allow you to specify the X, Y, Z component of the force. Okay. And if your units here are newtons, you can change the units here to pounds. And so you can go to home right here and change the units to pounds if you want. And so I want you to apply 100 pounds of force somewhere on this model, where, basically where the pedal is going to be. Okay. And for the direction of the force, I want you to think about, which direction is going to cause the most stress. Okay. Because remember, we're gonna try to put this bike crank into its worst case scenario. Okay. And so you have to think about, whether you want to apply the force this way, whether you want to apply the force this way. Okay. You can even have it come out of the page if you want, but you have to think about, you want to give it the worst case scenario, but it also has to be realistic. And so, does it make sense for someone to apply a force that goes out of the plane like that? Okay. All right. I'll give you a hint though. And so, I don't, the force is not in some diagonal direction. The force is either going to be the Y direction, the X direction, or the Z direction. And so you're going to choose one of those, which makes the most sense, and also puts the bike crank in, in the worst, in the position where it's most likely to fail. Okay. All right, so I'll give you guys maybe about 10, 15 minutes to work on that. You can try different things as well. And so as soon as you apply the force here, you can actually run the simulation. And so if you want to check your results, remember you can right click on solution A6. You can go to insert. Let's go ahead and look at the total deformation. And let's go ahead and look at the equivalent von Mises stress as well. Okay. Okay, and so if you want to test your simulation with your boundary conditions, you can go ahead and add those two results. You can go ahead and click on solve, and you can try maybe different configurations of the force that'll give you the most stress. Okay. All right, so I'll give you guys maybe until 6:20 to work on that. If you have questions, you can raise your hand. So I'll be kind of making my rounds. And if you're on Zoom, if you have questions, just drop something in the chat, and then I can kind of help you out. All right, so why don't I start with Zoom actually? So I kind of went around the concept. So is everyone on Zoom doing okay with the mesh and with the boundary conditions?
No.
Oh.
The pedals on this. Yeah, so remember, so you, once you brush the pedal, it's just over there. It's in the pedal grip. So this is the pedal side, this is the side.
They're making,
Okay.
I'm assuming.
So I didn't give you the exact answer, but you know, we're gonna think about the things important are really the right and also application for your geometry. Right, usually that happens. Some of them are based on real things. Wherever this likely. Right.
So you have this good thing.
Oh, it's probably on to it.
It's fine. Right.
Yeah.
Yes.
Yeah. Oh, for this activity. You're not gonna get there. But you know, for future, you can, exact.
Oh, you're feeling
Where exactly we want to do, where it's sliding. And it's just where.
technically the most information.
Exactly.
That's what that's not realistic.
You're gonna select,
That's what the shit is. But that's not right.
So for the, if you click on the question, if you go to the. Okay, so we fit here. We didn't talk about origins yet. This should be what the usual. But it should be. We'll talk about order. So then error. Yeah, so what we'll learn, probably next 2 days, if you use linear numbers with structural mechanics. Structural mechanics, generally want to use much better. And use the global setting, it'll default. It's kind of like not that.
Oh, the information and global distress.
Alright.
We get it. So you see the other my push down. So we get it before we are able. So maybe the force down. Eight. Because I push it down. Eight. We get it. I mean, I think the only one because it X pushing there. X.
Yeah, that'll do it.
Because I don't know when
It's fine, fix it in the inside of where the shop goes. Yeah. In there, the inner circle.
Okay, yeah, that's right.
It's like about that's the crest of the shaft, but don't go where the base of the shaft.
I can figure out how to do
That's where your metal goes.
Wait, go to the.
Oh, yeah. Oh, yeah.
I don't know why it's mechanics so. I think that's it doesn't matter.
Whatever. Did you change the side of it? Click on your, Because I have that issue pop up. But I don't know how to. Yeah. Some people are, yeah, because it just depends on where your feet are, because your foot is always parallel to the crane. So the crane- And if it say it's locked here, your vector, your orthodox going straight to the bottom.
Yeah. I mean, it would be the most,
The force should be the same throughout the whole time. You're putting the same amount of pressure on it. It's just that's the most force in the one vector.
That's one and.
Yeah.
How much?
I see what you're saying. Because you're. Yeah, but when stepping on here, you're putting the foot down. Maybe can you put the direction of this? You want it to be negative, so you're pushing into the part, assuming that's scenario.
All right, so if you apply the boundary conditions in the correct way, you should get a result that looks like this, okay? And so just because it'll be helpful for the future parts of this activity, you can go ahead and change the units. So, the units I'm using are US customary with 1 inch. Okay. The only reason this is useful is because, in a little bit, we're about to compute stresses in PSI. And so it's helpful if the stress values are in PSI. So if you go ahead and switch the units to US customary with inches, we can go ahead and do that. And if you want to check your result against mine, so under the default conditions with just 100 pounds, you should be getting a maximum equivalent stress of around 13,330. All right, it may not be exactly that. It may just be off by a couple numbers or not, but it should be kind of roughly in that same neighborhood. If you want your animation to play, I get this question all the time. And so when you're viewing the results, so it's either say the total deformation or the equivalent stress, there is a play button here on the bottom here. And so you can actually see your bike crank kind of forming. Okay, so I'll give you guys maybe about 5 more minutes, and then I'll go ahead and outline the rest of the activity. So this is it. And so this is all the new stuff we're gonna learn today. But I did want to go over just what you have to do for the rest of the activity. Wait a second. Let me take a look. Okay. Yeah, I mean, there shouldn't be
It's the smallest cross section area.
Yeah, so if you think about when you're going around the crate, even though you're at the top, and you're starting the crank is, the crank is still pushing down, so your force is getting pushed out when you're really because this vector, you're pushing straight down, and it goes straight down versus the circular.
Okay, so you're looking at strength. So what I'm looking at is stress. So go ahead and write that.
Click on the equivalent stress.
There's also
For me, it's good.
support for the load reaction line of force. So we know the unit vector. We want to straight. Yeah, anything or not.
Very far right.
There's something.
What else? Trying to catch up.
For sure. It doesn't, well, technically yes, but it's symmetrical, so. You'll get the same values of stress, it's just it'll be on the opposite side.
No, it is.
One small thing, so when you apply the force, you apply it. And so generally you want to. It's a small thing, so it's this one you often have to think of. Yeah, it's basically exactly what I thought of. But it's kind of better practice to apply it. But this one doesn't matter. You can cause an issue.
Because that's at the point where the, your vector, when you're at the top, you're still pushing down. So your components are kind of, give a large y, but there's still some.
Oh, yeah.
By the time it gets.
That's right. Yeah, so for the hexagonal method, it's almost impossible to create a mesh that's completely hexes. And so it's going to create some internal pyramid, some internal hex. And so this just tells you, I don't know why it tells you guys what to do, but there's nothing wrong. It's just reporting that. Okay.
Yeah.
So
Very small.
Yeah.
So you're making small, that's why the low days would be once you're powered through that.
All right, so it seems like everyone's doing good with the activity. So let me go ahead and outline the rest of the activity for you. Just so that that you kind of know what to work on for the rest of the day. So everything that we did today, we did up to problem 4. And so we were able to do the mesh, we did all the boundary conditions, we looked at the results, and we saw that they're good. Okay, so we did up to problem 4. Of course, in the activity, there are some questions you have to answer for problems 1 through 4. But everything that we did today is covered all that stuff. Okay, so the next part of the activity here, it actually goes back to what we talked about at the beginning, right? So we're not just running a simulation on this bike crank for fun, although it kind of seemed like that today. Okay. Remember, we're actually running a simulation on this bike crank to kind of test it for failure. Okay. All right, and so what we know is that based on the material that we're using, this aluminum 6061 T6, we know that it has a yield strength of 35,000 psi. Okay. And remember, when we reviewed strength of materials, what this means is that if the internal stress or if the equivalent stress in this bike crank ever reaches 35,000 psi, then the bike crank is going to fail. Okay, so that's how we're going to test it. And so if we look at our bike crank right now, you can see that my bike crank has a maximum equivalent stress of about 13,000 psi. So, and so we're good. And so under the default configuration, this bike crank really is in no danger of failing. Okay. And so for problem 5, what I want you to do is I want you to actually push this bike crank to failure. Okay, so I want you to basically push it, increase the amount of force until we get failure. Okay. Okay. And so for problem 5, we know that the yield strength is 35,000 psi. Okay. But like any good design, you're not going to push it all the way until failure, right? And so there's going to be some factor of safety. And so for this case, our factor of safety, we're going to use a factor of safety of 2. Okay. And so the way you use this is that, instead of pushing it all the way to 35,000 psi, we would do 35,000 psi divided by a factor of safety, which is 2. Okay. And so now instead of working with a maximum stress of 35,000, we're instead working with a maximum stress of 17,500. Okay. All right. And so what I want you to do with problem 5 is I want you to go back into your simulation. Okay, go back to your force boundary condition. Right. Right now we're only applying a force of 100 pounds. And so for this part, I want you to increase it. So instead of 100 pounds, let's say that we increase it to 150. Okay. And so what you should see is that if you increase the amount of loading that your bike crank is under, then the equivalent stress is going to go up as well. Okay, so we go ahead and click solve. And so you can see that increasing my force here to 150, you can see that the equivalent stress here went up to basically almost 20,000 psi. Okay. All right. And so for problem 5, I want you to basically do trial and error. So I want you to basically change this force, okay, and try to find the exact value of force such that the equivalent stress is 17,500. Okay? The maximum equivalent stress is 17,500. And so you know it's not 100, right? You know it's not 150 because 150 actually pushes it beyond that. And so the exact loading is somewhere in between 100 and 150. Okay? So I want you guys to kind of play around with that value until you reach that. 17,500. Okay. Okay, so that makes sense for problem 5. For problem 5, you're just changing the magnitude of the force until you get an equivalent stress of 17,500. Okay. All right. Problem 6, I want you to do the same thing, except I want you to change the direction of the force. Okay. And so for most of you now, I think basically everyone, your force is applied in the y direction. So we're basically stressing the bike crank and bending. Basically find a bending force. Okay. For problem 6, what I want you to do is I want you to change this direction. So instead of acting in the y direction, I want you to apply the load in the x direction instead. Okay. Specifically in the negative x direction, so that we kind of compress the bike. Okay. And so if you do that, you can see that the stress distribution is going to change, but the direction of the force is going to change, as well as the magnitudes. Okay. And so same thing. And so for problem 6, what I want you to do is that with the force in the negative x direction, I want you to increase that force until you reach that point of 17,500 psi. Okay. All right. So does that make sense for problem 6? Okay. Okay. Yeah. Question.
So when we take a poll, we want to do them near the 17,500.
Yes. Yes, as close. You don't have to get it exact, and so it's going to be really hard to get it exactly there. But anywhere within 500 is fine. 17. Yeah. So anything between 17,000 and 18,000 psi is fine. Yeah. Okay, so that's problem 6. I always forget to fix this every year, but there's a problem 6 part 2. Which has actually nothing to do with the previous problem 6. But for the next part, what I want you to do is I want you to summarize your findings. Okay. So this is going to be a recurring assignment or recurring problem for every ANSYS activity. Okay. Because one thing that you'll learn very quickly, when you do FEA, is that it's important to know how to do FEA, right? But it's equally as important to be able to communicate your findings to other people. And so in problem 6, I want you to kind of, think about how are you going to best communicate what you found, kind of the information that you found in this activity to someone else. Okay. And so usually what I tell people for the activities is, imagine that you're writing an email. And so maybe you're writing an email to your manager and you want to summarize, your findings in kind of a one-page format. Okay. And so for the summaries, try to keep them to one page and think about, how can you best communicate the main results of your FEA, and any recommendation for the design. Okay, and so this is going to be a big part of all the activities going. All right, and then finally for the last part of the activity, this is where the other CAD file comes into play, and so I want you to do an analysis on a bike crank. Okay, so I'm giving you another CAD file. So just like you did with the bike crank, I want you to mesh it. I want you to apply boundary conditions, and I want you to examine the stress and deformation. And so more information about where to apply the forces and what mesh to apply is there. Okay. And this is just to kind of give you practice with another geometry, just so that kind of get into the practice of meshing, apply boundary conditions, apply material properties, and all that stuff. Okay. All right. Any questions on the rest of the activity? Okay, all right, so we have about 15 more minutes of class, and so I'll stick around until about 6:45, so you guys are welcome to keep working on it. Anyway, if you want to work on this at home, you're welcome to go as well. And so, for those of you that are leaving right now, so I just want to thank you guys for coming today. Hopefully you enjoyed our second ANSYS activity. Next week, we don't have an ANSYS activity, so we have a lecture on Tuesday, a lecture on Thursday, so no ANSYS next week. and then we'll pick up ANSYS again in 2 weeks. Okay. All right, so thank you guys for coming today. Hope you guys enjoy the rest of your evening. And so I'm sticking around. So if you're sticking around, then I'll see you here too. But if you're heading out, then I'll say have a good weekend, and I will see you guys next week. Exactly. Yeah. It's fun trying to get I know, yeah.
From viewers, it's. Guys.
It's fun. It's fun.
Yeah.
That's pretty good. If you're within 10.
Yeah. Yeah.
That's.
Yeah.
Two.
That's true.
Well, that's what I've been. Mine?
Nope, but the zip line.
Yeah.
I forgot to do that.
Yeah.
But I was when I started when I got here, it was trying to. It's not like wherever you can get it, like AutoCAD and all the other software. You didn't see it. I couldn't do it. Forgot besides.
Oh, yeah, do you know?
Yeah.
I could. No, it took me like 10 minutes to do this. So it was like, oh, yeah.
That way I can see.
Yeah, there is.
Toronto.
Oh, yeah, I'm gonna do it after like.
That's the entire point. I think he also hosted online. Guess I'll read.
Oh, which one are you? Which team did you listen to?
Oh, I didn't even
Oh, he
check.
sent the email.
Bro, I like to give so bad. I was like, I'm not getting anything, you know?
Yeah.
He has the second one,
Just
but
sit
solar
perfect.
sun.
Oh, that's it.
Not the solar, the first one.
I got it.
There's no way I'm getting. It's so fun.
Wait, do you have Jim Lee?
For your sake. Yeah.
You know what they're doing this year? About this one.
Yeah, I know.
So basically, like,
It's like a week. But it takes like a lot of time to like hang on the track and like unhook the bar and bring them around. They want it like.
I want to wait away from passengers. Or the The other one was more dope, though. They like figure out how to power on the cars and boats.
okay, because like had that.
Wait, so is this the same?
The WBPZ. Slow.
And then this was upcoming Monday, like the
This one, yeah, with the, like.
So
double click
it's free for any college student, you have to go into the pantry.
Or I guess right.
And then you make an appointment, yeah, you sign.
Easy, yeah, that's it. Oh, so until there's this one. I mean, I'd say.
Next month, did you ever finish the deposit thing?
Wait, so are you doing that this year? Or?
Yeah, well, no, I wanted that one, but I got put it,
Oh,
yeah.
It's fine.
I was gonna say, as soon as I do it, I forget, like, going to the
Went back later. I don't know if this is, I don't know if they realize that. But I haven't.
You just open up your home portal.
Yeah, I would do that, but. Yeah, I would still go with it. Okay.
I don't know.
Let's say,
They're small.
it's like an active.
Yeah.
Now I can.
I think I got them all.
Go to your time portal.
I need what?
This is a different layout. I felt like
Well, I'm
stuff
assuming
up,
it-
it's not showing.
Oh, no, they use this with the other.
Yeah. Well, what if one of these?
Because it was literally just the thing on the.
Yeah, like
To your point.
I think so. Yeah, we're.
It's not that, it's going to be like underwhelming.
Again, I have no idea what the episode is. Yeah, bro, I don't know. Right now it's being. Oh.
So that.
Yes.
Do you feel like,
You can try it now.
Yeah, it's there.
Yeah, but it's just one of them.
work at
Because you're opening.
Yeah.
Yeah.
So that's.
Yeah.
That's why I opened the,
I'm gonna show you.
how do you open that? I haven't tried this once. Yeah, if you want to. I had like no energy on today I feel like much better. Tuesday I was really still kind of that. I didn't drink that much. Yes. Well, wedding, we'll see what happens. I'm like a buy one, get one free. Like, for like seasonal drinks every third day, like, I don't know, the next couple weeks. Oh, sorry, Bob. We don't reset it. I'm just gonna say, behind on it. I'll go back right now. Yeah.
You can contact the e-commerce.
But it's.
Like, compared to my stock, it's crazy.
Compared to like
Someone without a cat.
Oh, look,
I'm pretty sure.
As